Okay, so this is question 4, part A. So we've got g of x is our function, which is 1 over x, and this part here is the domain of our function. So we're told x can take any real number as long as x is greater than or equal to 3. So the best way to get the range of the function, which we'll ask for in part A, is to draw a sketch of the graph. So any question asks you to find the range, best way is to sketch the graph of that function. So we know x can take any value greater than or equal to 3, any real number, as long as x is greater than or equal to 3. So if we choose x equals 3, 1 over 3 would give us 1/3. If x is 4, 1 over 4 would give us 1/4. 1 over 5 would give us 1/5, etc. And that graph would continue getting closer and closer to our x-axis, but never actually reach it. So the values that g of x can take, the biggest value g of x can take is equal to 1/3, and that's when x equals 3, and then g of x can never end up being a negative or 0. So for part A, g of x will always have to be a value greater than 0, because it's always, the graph's always going to be above the x-axis, and the maximum it can ever get to is the value of 1/3 when the x value is equal to 3. Just rub that out so it isn't very clear. So that's our range for g of x. Part B, we're asked to find the inverse function. So if we let y equals 1 over x and rearrange that to make x a subject, x will be equal to 1 over y, and therefore our inverse function, g to the minus 1 of x, will be 1 over x. So actually the inverse and the function are exactly the same as each other. So we then need to find the domain and the range of our inverse. Now the domain of our inverse will be exactly the same as the range of our original function. So the domain of the inverse is the same as the range of the original function. Now we've just worked out the range of the original function here. That was the range of g of x, so that will be the same as the domain of our inverse. So that means the values for our inverse, x can take any value greater than 0 and less than or equal to 1/3. Now we probably should have put here, g of x can be any real number, and similarly x can be any real number there. And then we've also asked to find the range of the inverse, and the range of the inverse will be the same as the domain of the original function. And if we look back, the original function had the domain here. Given in the original question, the domain was x can take any real number as long as x is greater than or equal to 3. So that means that g to the minus 1 of x can be any real number as long as g to the minus 1 of x is greater than or equal to 3. So we've now got the range and the domain of our inverse, and then it asked us to sketch the function and its inverse. Now a function and its inverse will always be reflections of each other in the line y equals x. So if I draw the line y equals x onto my grid here, okay, that would be the line y equals x. If I reflect my g of x graph, which is this one down here, so this is my g of x, we look at our inverse function was 1 over x as well, but for that one our domain was x could only be any value between 0 and 1/3. So we're only looking for x running between 0 and 1/3. Now if x was 1/3, 1 divided by 1/3 would be equal to 3. If we took a value less than 1/3, like 1/4, 1 divided by 1/4 would be 4, 1 divided by 1/5 would be 5, etc. So our graph here, that would be our graph g to the minus 1 of x. So it's a reflection of our g of x graph in line y equals x, and we can see our domain is x can be any value between 0 and 1/3, and the range, well, the lowest value that g to the minus 1 of x can get to is 3, and the graph continues upwards indefinitely, so there's no maximum, but the value will always be greater than or equal to 3.